December 1968. The Canadian winter is unforgiving, but the atmosphere inside the train is electric. The press, politicians, and engineers have gathered to witness a revolution. They are on board the UAC TurboTrain for its inaugural press run. This machine wasn't just a new locomotive, it was a promise. Designed by Aerospace engineers and powered by Pratt Whitney jet engines, it looked like a spaceship that had landed on the tracks. On its test runs, it shattered records, hitting speeds of 170 miles per hour. It was faster than a Ferrari and smoother than a Cadillac. It was supposed to be the savior of the American railroad. But less than an hour into this victory lap, disaster struck. At a crossing near Kingston, Ontario, the futuristic train collided with a truck. The aerodynamic nose, designed to slice through the air, was smashed instantly. The headlines changed from "The Future of Travel" to "Turbo Hits Truck." And that was just the beginning. In the weeks that followed, the brakes froze shut in the cold, the engines caught fire, the passengers were trapped in freezing, burning nightmares. This is the story of the UAC TurboTrain, the most advanced, beautiful, and catastrophic train North America ever built. This is the story of how we tried to make a train fly, and why it crashed back down to Earth.
To understand why this machine exists, we have to look at the 1960s. It was the jet age. The Boeing 707 was shrinking the world. The interstate highway system was expanding across the continent. Americans were falling in love with speed and convenience. And the passenger train? It was dying. Railroad companies were going bankrupt. Stations were empty, trains were seen as slow, dirty relics of the past. The journey between Boston and New York took over 4 hours on rattling tracks. The United States government realized they had a crisis on their hands. The Northeast Corridor was becoming gridlocked. They needed a train that could compete with the airplane. But they had a major problem: the infrastructure. The tracks were old, curvy, and outdated. Building a new high-speed line like Japan's Shinkansen would cost billions of dollars and take decades. They needed a shortcut. They needed a train that could go fast on bad tracks.
Enter the United Aircraft Corporation. They didn't build trains, they built jet engines. Their engineers looked at the problem and said, let's stop building heavy locomotives, let's build a fuselage on wheels. Their solution was radical. They took the Pratt Whitney PT-6 gas turbine engine, a marvel of engineering used in helicopters and small aircraft, and modified it for the rails. These engines were tiny compared to massive diesel blocks. They weighed only 300 pounds but produced incredible power. The design was pure aerospace. The train was built from aluminum, not steel. It was lightweight and streamlined. But the real magic was in the suspension. The tracks in America were twisted and full of sharp curves. A normal train has to slow down for a curve to keep passengers from sliding out of their seats, or worse, to prevent the train from tipping over. The UAC engineers developed a pendular suspension system. The train cars were suspended on A-frame arms. When the train entered a curve, centrifugal force would naturally swing the car body outward, banking it into the turn, just like an airplane or a motorcycle. This meant the turbo train could take curves 30 to 40% faster than any other train on Earth, without spilling the passengers' coffee. It was a brilliant concept. On paper, it was perfect.
Inside, the TurboTrain was unlike anything the public had ever seen. It was designed to feel like a jetliner. The interiors were pressurized to keep out noise and dust. There were stewardesses serving meals at your seat. The lighting was soft, the seats were plush.
And then there were the dome cars. At both ends of the train, passengers could sit in a raised glass observation deck, looking out over the roof of the train as the world blurred by at high speed. It offered a panoramic view of the future. During testing on the Pennsylvania Railroad in 1967, the TurboTrain achieved a speed of 170.8 miles per hour. To this day, that remains the speed record for a gas turbine-powered train. The engineers were ecstatic. They had done it. They had brought the speed of flight to the rails. But there is a reason airplane engineers don't usually build trains. Planes fly in clean air. Trains run through dirt, dust, snow, and debris. The TurboTrain was a delicate, high-performance machine operating in a brutal environment. The problems started immediately. The complex suspension system was a maintenance nightmare. It had too many moving parts. The banking mechanism was sometimes jerky, making passengers seasick rather than comfortable. And then there was the noise. Those gas turbines were essentially jet engines. While the interior was quiet, on the outside the train screamed. When it pulled into a station, the high-pitched whine was so deafening that people on the platform had to cover their ears. It sounded like a 747 was taxiing on the tracks. But the real killer was the cold. When the TurboTrain entered service in Canada for CN Rail, the harsh winter exposed every flaw. The moisture and the pneumatic lines froze, locking the brakes. The fancy, futuristic doors jammed shut with ice. The heating systems failed. The space-age train was defeated by simple ice and snow. It spent more time in the repair shop than on the tracks. On one occasion, the train broke down so completely that it had to be towed by an old-fashioned diesel locomotive, the very technology it was supposed to replace. It was a humiliating sight. The reliability issues were compounded by danger. The braking system was notorious. In cold weather, the brake shoes would sometimes drag against the wheels without the engineer knowing. The friction would build up tremendous heat until the undercarriage literally caught fire. There were incidents where the train would arrive at a station trailing black smoke with flames licking at the aluminum body. The public lost confidence. The TurboTrain became a joke. Amtrak tried to operate them in the United States, and Via Rail took over in Canada. They spent millions trying to fix the issues. They upgraded the engines, changed the suspension, and improved the insulation. And for a while, in the late 70s, the TurboTrain actually provided decent service. It was fast, breaking the record for the trip between Toronto and Montreal. But it was too late. The 1973 oil crisis changed everything. The TurboTrain was a gas guzzler. It burned aviation fuel, which had suddenly become incredibly expensive. A train that consumed fuel like a jet plane no longer made economic sense. By the early 1980s, the dream was over. Amtrak retired its TurboTrains, and Via Rail followed suit. The magnificent aluminum birds were sent to the scrapyard. It is a tragedy of engineering. Most of them were crushed into cubes or melted down. Today, almost nothing remains of the TurboTrain. No complete train was preserved in a museum, just a few scattered parts and fading photographs. So, was the TurboTrain a failure? Technically, yes. It was too complex, too fragile, and too thirsty. It was the aluminum Icarus. It flew too close to the sun with technology that wasn't quite ready, and its wings melted in the heat of reality. But in spirit, it was a success. It proved that high-speed rail was possible in North America. It showed that trains didn't have to be slow and boring. The lessons learned from the TurboTrain paved the way for the tilting trains of Europe, and eventually the Acela Express in America. The UAC TurboTrain was a beautiful, flawed vision of the future. It was the train that tried to be a plane, and for a brief, shining moment, it really did fly.
History is written in the past, but the future of rail is being built today. For the latest technologies, industry news, and engineering breakthroughs, continue the journey at railwaynews.net.